Hey guys, we're going to do our flip video on chemical bonding. So let's go ahead and get my presentation pulled up. So with chemical bonding, we need to look at this as if it's like a dating activity for elements. All right, so chemical bonding is basically dating for the elements. So we're going to talk about why elements need to bond and then what are the examples of the different types of bonding. So let's talk about the why first. Okay, atoms need to feel stable. All right, in order to do that, they have to bond with other elements in order to make that stability happen. Okay, and we're talking about valence electrons. And valence electrons, all elements on the periodic table follow the rule of 8, which is known as the octet rule, which we've talked about this, except 4 elements. Okay, and it's the first 4 elements on the periodic table: hydrogen, helium, lithium, and beryllium. And the reason they follow a different rule is because they're just low-numbered elements. They don't have very many electrons anyway. Okay, they follow what is called the rule of 2 or the duplet rule. All right, and so these elements or atoms need to feel stable. In order to do that, they have to bond using their valence electrons with other elements. But it's not just like, oh, these 2 elements can get together and everybody's stable. All right, there's specific rules they follow based on what they're looking for. It's kind of like a relationship. You're not just going to go out and date anybody. You've got to find somebody that has common interests as you. Okay, so to feel stable, they are going to lose or gain valence electrons. And valence electrons are those electrons in the outermost shell. There are 4 types of bonding, 2 of which we're going to talk about in greater detail. We're going to talk in great detail about ionic and covalent, but there's also hydrogen and metallic bonding as well. So let's start with ionic bonding. All right, why is it called ionic bonding? It's because this occurs between 2 or more ions. Ions is a vocabulary word that we've talked about very briefly, but to refresh your memory, an ion is basically an atom that has a charge, plus or minus. And why does it have a charge? Because it's either gaining or losing electrons. So if you think about the elements, remember we're trying to follow the rule of 8. If I have 1 valence electron and I'm trying to get to 8, is it easier for me to lose that 1 electron, or is it easier for me to find 7 electrons to make me stable? It's easier for me to lose that 1. All right, when I lose electrons, I'm losing a negative particle, which becomes I become more positively charged. Okay, ionic bonding occurs when metals give their nonmetal friends their valence electrons. All right, and so the elements on the left-hand side of the periodic table are going to give up electrons to elements on the right-hand side of the periodic table. And remember, our rule is 8. Metals are going to lose electrons. All right, so those elements on the left are looking to get rid or lose electrons. They'll become more positive because they're giving away some of their negativity. Nonmetals gain electrons, they become more negative. Why are they gaining or why are they becoming negative? Because they are getting negative particles from those metals. An example, Na, which is on the left-hand side of the periodic table, it's a metal, gives up an electron, that's why it has the plus sign. Chlorine is going to take that electron and become negative because it has more negative particles. That makes NaCl, which is table salt. In ionic bonding, these compounds that are created typically are good conductors of electricity. They have a very high melting point and are typically solid at room temperature. Our next one is covalent bonding. Covalent bonding occurs between 2 or more nonmetals, and they don't give up electrons, they actually share. All right, so those nonmetals are those elements on the right-hand side of the periodic table. All right, water is a great example of covalent bonding. So let's take a look at how water bonds to be covalent. First of all, you have 1 oxygen in the compound H2O. Oxygen is in column 16, which means it has 6 valence electrons. Okay, remember it's trying to get to 8. Hydrogen has 1 valence electron each, and in the compound H2O, that 2 signifies there are 2 hydrogen atoms. So what will happen is hydrogen will share each of its 1 electrons. All right, it will then become stable because it's following the rule of 2. Oxygen is looking for 2 electrons to share, all right, to become stable with the rule of 8. So the oxygen atom will share its 2 valence electrons with the hydrogen atom to become stable. This creates a water molecule. All right, so molecules are created when electrons are shared through covalent bonding. Here's a picture of what that would look like. You have your 1 oxygen atom here with its 6 electrons, 1 hydrogen atom, another hydrogen atom. They become covalently bonded because they are sharing electrons with each other. Now, these molecules typically do not conduct electricity well. They have very low melting points, and they're either a liquid or a gas at room temperature. So those are the 2 we're going to talk about pretty significantly, but we do need to talk about the other 2. All right, hydrogen bonding is exactly what it sounds like. It occurs when two or more hydrogen atoms bond within a compound or a molecule bond. All right, so what does that even look like? Okay, so here's a picture. We have a water molecule, water molecule, water molecule. These hydrogen atoms are covalently bonded to these oxygen atoms. But when this water molecule wants to bond to this water molecule, that is creating a hydrogen bond. Then this water molecule creates or attaches or bonds with this water molecule through a hydrogen bond. These hydrogen bonds are pretty easy to break apart. All right, and as they start to link, you get all of these different water molecules bonding hydrogen bonding with each other. You get things like a large body of water. All right, so basically, if you look at a lake, a stream, a puddle, any of that, it is just linked together water molecules through hydrogen bonding. And our last one is metallic bonding. All right, this occurs when two or more metals bond with each other. And those are elements in that middle section of the periodic table, typically, that one that we sort of ignored, we'll call it, because we don't really talk a lot about metallic bonding, but when you get to high school and take chemistry, that will certainly be a large topic for you.